Well, good evening, and welcome to Copernik Observatory. My name is Drew Desker. It's great to have a nice crowd here this evening. I'm the director here at Copernik, and so I always got to find out who's here today. So who's here for the first time or not since your fourth grade field trip? All right, not too many. How many people here are members? Oh, about the same number, but on the other side. All right. Well, why I bring that up is that Copernik is a nonprofit, and we belong to what's called the ASTC, Association of Science and Technology Centers. And it is a consortium of over 380 other science centers that honor each other's memberships. So a Copernik membership will get you into Roberson. It'll get you into the Museum of Science and Technology up at Syracuse, or the Franklin Institute down in Philly, or the Intrepid down in New York City. So if you sort of like this kind of place, consider getting a Copernik membership. It gets you into any of our events here for free, but again, you have the opportunity to hit these other facilities. So let me switch over to my get out of Stellarium here and talk a little bit about Copernik. So our website always keeps you up to date with what's going on. Always our Friday night programs are here. We're actually coming up is a race. We have a 5K race called Race to the Stars. It'll be September 6th. It's an out and back race on the flat part. So for those of you that drove up from Underwood Road, we don't go there for the race. We figured that would winnow down the number of people that would actually be interested in running. But not only runners, but walkers will also do it as well. So, like an evening out, and also at the end of the race, after the awards ceremony, we hope to have clear skies, and then you'll have an opportunity to do some viewing there as well. One of the things that we do here, well, during the school year, we have school groups come up. We also take our educators out to schools, but we do offer week-long summer camps, and we just Super Kids Helping Save the Planet, but we also did one on virtual reality and augmented reality, where students built their own 3D environment that they would then run on Meta 3 virtual headsets. Next week, actually, I'm running a camp called Return to the Edge of Space, where our students are going to build a payload that will launch on a weather balloon that will go up to over 100,000 feet. We'll fly a number of cameras, including one of those 360 cameras. That's a new one for us this year. We're also going to fly a Geiger counter to get a sense of what kind of cosmic ray exposure we get at different altitudes. So I'm looking forward to that. But one of the things that we've been doing, let me go back here. This is our 33rd year of doing these STEM summer camps, and some of our alumni have gone on to pursue STEM careers. Some now are actually teaching in university. So for those of you with young students, definitely check out next summer's STEM summer camps. It's always a lot of fun. But for me, one of the things I really enjoyed most are these Friday nights. It's an opportunity for us to actually learn about a wide range of topics, not always astronomy. Or what's necessarily in the sky, although today's actually happens to be about that. And one of the things we do here is we live stream all of our programs. So we now have we have a YouTube channel now for a number of years, but we have nearly 14,000 subscribers that watch. And what's also great about it is that, so if you can't make it up here on any particular evening, you can always watch it on on the live stream, or if you're just busy Friday night, you can go back and watch it at your convenience. And literally, there are 5 years worth of our programs here. So last week we had Atom Thin Adventures, Unleashing the Superpowers of Ultra-Flat Materials, What's Causing Butterfly Decline. We had a talk about Planet X, the Galapagos Islands, AI. So it's not always about astronomy, and it's always quite interesting. But also, we do a number of live stream observation programs. So we've had, whenever there's a an eclipse or a meteor shower, if the conditions are right, we will live stream that as well. In fact, actually, Jenny Carty, our live stream astronomer, back in March did there was a lunar eclipse back in March that you may or may not have known about. You probably didn't know about it because it started at 2 in the morning. But Jenny was here and basically live streamed the entire thing, but took that basically the equivalent of about 5 hours worth of video and compressed it into a 1-minute compilation time lapse of the lunar eclipse. You can start to see the Earth's shadow start to cover the moon, and eventually Jenny will change the exposure so we can actually start to see, like right there, you start to see the dark, the unlit up part of the moon. And now we're finally into that time people call the blood moon, which is really just light refracting through our atmosphere. It's the long wavelength light, the red light. So it's not the end of the Earth. It just happens to be always, anytime there's a full moon, there's a lunar eclipse, it'll always look red. And then finally, it came out from, changed the exposure back and start to see the moon as we would normally see it. And what's nice again about these live streams, literally people from around the world are watching this. In fact, this evening, Lindsay from our friend in Adelaide, Australia, is watching. Actually, it's 10 o'clock in the morning for her right now. So she finished breakfast, is putting away her breakfast dishes, and is watching our program this evening. So definitely check out our YouTube channel. I just learned this afternoon that Commander Jim Lovell of Apollo 13 passed away yesterday. He was 97 years old. And this is a picture of Commander Jim Lovell. He was actually up here. So actually sort of behind my screen here, there's a cornerstone that would normally sit right in here. And there was a time capsule behind there, and that's a story for another time. But yes,
it could have a massive impact on the future of life on Earth. The thing about the moon is that the more we learn, the more...
Okay, well, we'll make that go away. But anyway, let me go back to Commander Lovell. This is 2 years after the Apollo 13 mission. For those of you who don't remember, there were supposed to be 7 Apollo missions that were going to go to the moon and land. Apollo 13 was going to be the 3rd one. On its way to the moon, there was a major explosion on the service module, and they were unable to land on the moon. But through the engineers and the bravery of the astronauts, they returned safely. So this is actually 2 years after the Apollo 13 mission. One thing I learned is that, did anybody ever see the Apollo 13 movie with Tom Hanks? Did you know Jim Lovell was in that? He had a little cameo. So there's Tom Hanks. This is Jim Lovell off to the left. So basically, when they came back, returned to, when Tom Hanks returned to Earth, as it were, and they came off of the helicopter, he was greeted by the captain of the ship, who was originally Ron Howard, who was the director, wanted him to be dressed as an admiral. And Jim Lovell said, I left the Navy as a captain. I'm going to wear the captain's uniform. That actually was his naval uniform that he wore as part of the, you literally saw him for about 3 or 4 seconds. But he was, in fact, in the Apollo 13 mission. So he died yesterday, and just what an absolute inspiration he was to many of us. And so clear skies for you, sir. All right, well, back to our program here. We are actually one of the better observatories in the Northeast, and so whenever we can, we always try to promote people looking up into the skies. There are always interesting things to see in the skies. Tonight we're going to talk about the Perseid Meteor shower, and Roy Williams, who is one of our Kopernik educators, has done this program a number of times, and we're glad to have him back and to join us this evening. So I'm going to get you back on your slide here, and is that it? All right.
All right. I just turned on my sound, so am I
Yep.
good?
We'll find out.
Okay. All right. Well, thanks a lot. Thanks for coming up. It looks like we're going to have a clear night. I'm Roy Williams. I taught many years here. Right now I'm teaching up near Oneonta. I teach science at Charlotte Valley School up in Davenport, New York. And so I'm down here once in a while, and I'm going to be teaching a class in a couple weeks down here on rocks and minerals. And anyway, so tonight, comets and meteors. I'll give you a little preview on the Perseid Meteor shower, what's going on with that, how to observe it, and so forth. All right, so let's get started here. All right, so just go over some terminology here. So you got comets, you got asteroids, you got meteoroids and meteors. We'll go into that in more details. But a comet is a solid body made of ice, rock, dust, frozen gases. And so it's considered to be a dirty snowball. Okay, we'll get to make one in just a few minutes. They are very fragile, and as they get close to the sun, they start boiling away their gases, and that's why they form their tail. Asteroids are small, rocky, iron or stony objects that are in the solar system, 1 meter to several hundred kilometers. And meteoroids are considered smaller. Anyone from microns to a meter is considered to be a meteoroid. We'll go into that a little bit more, but let's see. And if you have any questions as we go along, just raise your hand. So when a meteor, if you see one tonight or over the next few days, over the meteor shower is going to peak later on this next week. You got, if it's brighter than Venus, we call that a bolide, okay? And so it's very bright. Venus is on the magnitude scale is -4. Long story why it's negative, but anyway, it's very bright. The full moon you'll see tonight is -12, to give you an idea. So you can't miss a bolide, okay? Meteorites are after we find them on the Earth, we call them meteorites, all right? And they can be iron or they can be stony. I got some right here. Let's see. Here is an iron meteorite, so I'll pass that around, and you'll see that it's magnetic. Here we go. Here's the. Okay, so this is made of iron. All right, and then we have a stony meteorite. Now there's actually there's probably more stony meteorites than there are iron meteorites, but iron meteorites are so much easier to find because you got, metal detectors can find them very easily. So we'll pass that around, and then here you go. It's real heavy. So, all right. So yeah, pass that around so everybody gets to see it. So yeah, there's comets come through all the time. There's typically a couple comets out in the sky. On any given night, there's a handful of comets out there. Most of them are so dim you can maybe only see them with a large telescope. But once in a while, they get bright enough. And we had a visitor last year that came by, and this comet was taken here at the observatory. And you can see it has a very long tail. And what that's doing is that is pointing toward the sun. In other words, the sun is over here this way. And so what's going on here, you have the sun over here, and then you have something called the solar wind that's coming out from the sun. This is stripped protons, hydrogen gas, stripped protons. They're speeding away at 1,000,000 miles an hour. And here's the comet, let's say, and it makes the tail go directly away from the sun, so to speak, or you can say it's pointing toward the sun, or pointing away. And then you'll notice, I don't know if you can see it on the monitor. I can see it. I'm not sure if you can see it on the screen here. Yeah, kind of. Yeah, you can. There's a faint anti-tail. Once in a while, the tail can go in that direction too. So that's called an anti-tail. Now we're going to see some comets that have more than one tail, and I'll talk about why that happens too. And I think we got a couple more of this. Yeah, so. All right, there we go in our playground. Now, that wasn't during the daytime, I'm assuming. I think the shutter was open so long, it looks like it's daylight out. Do you know more about this?
Yeah, no, it was taken with a Google Pixel.
Oh, okay. Oh, okay. Wow. Okay. Wow. The tech can't keep up with this technology. Pretty soon the phones will be doing everything for us. Okay. So, yeah, you got, I did see that pixel thing. I was wondering what that was. Okay, so, yeah, more pictures of comets. So throughout the years, we've seen some amazing comets here at the observatory. Okay, here we go. We got some more people coming in. There we go. So, thanks. We'll get you more seats, more chairs. Yeah, so we've seen some amazing comets here. And just there's a little nomenclature that goes along with how they name comets. C is for comet, the year of the discovery, and then this is the third comet discovered that year. All right, and then this is who made the discovery. Atlas, when you see the word Atlas, that stands for Terrestrial Impact Last Alert System. It's an automated telescope that they're scanning the skies to find these things. We're very interested in finding near-Earth objects that might be able to strike the Earth. And about 30 years ago, we had very few orbits. We maybe had 10% of the orbits known. Now we're confident we have over 90% known. So we're a lot better off now. Less chances of getting surprised by something to hit us. But it could still happen. Even if you have 99% mapped out, you could still get hit by something. But, okay. So this is Comet Hale-Bopp. This was taken with a small telescope on the back of our 20-inch telescope. You'll see a 80-millimeter refracting telescope, real small, but it rode piggyback on the 20-inch to allow it to track the comet real accurately. And this was during perihelion, when the comet was closest to the sun. And so you get these two tails. And this right here, the blue tail, is called the ion tail, the gas tail. And that's caused by gas that's actually glowing. That solar wind is energizing the molecules of the comet's gases, just like the lights here, the fluorescent light. Oh, they might be LEDs now, but the fluorescent lights, you know, they have a gas in there, and you energize it, and it glows. And so you actually saw this naked eye. You could actually see the blue and everything. And then the other tail, kind of, see how it curves? That's called the dust tail. When I make the comet in a few minutes, you'll see that it's falling apart. And that's the material that's falling apart on the comet. And it's reflecting the sunlight. So this is reflected sunlight, and it kind of marks the orbit, because if you just kind of pretend in your mind, see how it curves a little bit? And then this guy, the blue tail, is pointing away from the sun because of that solar wind. So Comet Hale-Bopp was around for many months. It was really visible. Raise your hand if you got to see it here. Okay, all right, that's good. There's still a few of us left. Okay.
Is that gas tail similar to the northern lights that we see?
Well, it's similar process to why it's glowing. Yeah, but different gas. Yeah. All right. And more, that's that picture we saw before. And to give you an idea of comparison, we're going to make a comet. We're going to make the nucleus of a comet. So to give you an idea of size, most of them are a few miles across. Halley's Comet, 7 miles across. Hale-Bopp was 46 miles across. So it was intrinsically very bright. We were watching it in 1995 with the 20-inch when it was out at the orbit of Jupiter. So we were watching it for a long time. And we really had the vibe that it was going to be spectacular. So, but comets can fizzle. So you can get your hopes up, and a lot of times they kind of fizzle. I'd say most of the time they kind of fizzle. And they don't show up to be as bright as you want them to be. Okay, where do they come from? Well, comets come from something called the Oort cloud. So you have this region of space where here's the sun, and this is numbered off in AUs, astronomical units. So instead of telling you how many billions of miles it is, what we do is we go from the Earth to the sun, and that's one astronomical unit. All right. So it's a yardstick that we can use. Okay, so you can kind of see Pluto's out here at about 30 or 40 AUs, and it's the innermost Kuiper belt object, okay, minor planet, dwarf planet. And then you have the Kuiper belt, which goes out to about 1,000 AUs, and then you start getting into the Oort cloud. So it's very far away. What this stuff is, we believe, is that the solar system formed out of a huge cloud of gas. It condensed, most of it went into the sun, and created the sun, and then just by chance there was places of just where there was just higher gravity, just like a snowball effect, formed Jupiter and Saturn and the other planets. So anyway, the leftover material outside of that nebula is this pristine material that forms the comets, which is why we're so interested in sampling and getting. And we've had flown spacecraft that have actually captured some of the cometary dust. So that's capturing real pristine early solar system material. So that's very important. I think that's my clue to go to my other slideshow. Here we go. So. Whoops, current slide. So things that fall from the sky. Let's talk about what a meteor shower is, okay? Because it can be cometary dust. It can also be asteroid dust as well. But so things that fall from the sky. There are many small chunks of matter orbiting the sun. A piece that is in space, we call it a meteoroid. All right. How's our meteorites doing? They're coming around. Okay, good. And then when it streaks through the sky, we call it a meteor or a shooting star. Okay. And then when we find it on the ground, we call it a meteorite. Okay. So those are the three terms. So what about the ones that we don't find? Because most of them we don't find, right? What are those called? Meteorongs. Okay, so anyway, all right. So when back in the day, in the 1700s or even further back, or maybe even in the 1800s, people debated about what these things were, right? Some people thought they were atmospheric effects. So you can dig into that and find out what people thought. That's always kind of interesting. But I know. Back in the day, people were very, it's ominous. Comets were considered to be very threatening and ominous, like omens type of thing. So, all right, so what's going on here? Why is it every August 11th? So basically, the Perseids is August 11th through the 13th. I think this year it's best on the night of the 12th to the 13th is the peak. Okay, but go out there wherever it's clear. Don't you know what I mean? So, and really it starts at about a week before, or 10 days before, and 10 days after. You can still see some meteors. Okay, we'll talk about the numbers in just a little bit. But what's going on here? The reason why it's every August, middle of August, is that this is a comet came through, Comet Swift-Tuttle. And it comes through every 133 years as it orbits the Earth, and it leaves a debris field. Okay, it's going to leave this material behind, and then once a year we pass through it. Okay, so there will be times that this debris field is shifting, and typically a few years after it comes, it came in 1992, and then the last time it came by, so it's going to be a while before the comet comes back. But anyway, it leaves this debris, and the Earth passes through this debris. And that's why after midnight's the best, because the Earth is turning into that debris directly. So that's why after midnight it's the best time to view it in general. But you can go out there whenever it's clear. In our neck of the woods, whenever it's clear, there's no Canadian smoke. That's the way to do it. But there's different meteor showers. So the Perseids is August. The Orionids are really nice. They're in November. Yeah, thanks. Yeah, that's good. They're in November. November is the Leonids. And speaking of storms, okay. So what happens is I didn't tell you about storms. I thought I did. So what happens is that when these comets come in, they'll refreshen that debris field, and it might not happen that year or the next year, but this debris field will shift in space. The thickest part will eventually hit that thick part of it, and we'll get a storm, okay? And the Leonids are very famous. It's the one in November, very famous. In 2001, we got to see the Leonid storm. It was also big in 1833, which I think Abraham Lincoln got to see it. But in 2001, it was, we saw it up here. It was clear. And we watched it all night long until the sun started coming up. And we were seeing 5 to 10 meteors per second. That's how many. It was really amazing. There were just you thought you were seeing things. A lot of them were faint, but they were just, and it was actually picking up as the sun was coming up. So I think people west of us, like in Ohio or whatever, probably got it even better. The next one comes through. I'm forgetting the year now, but it's going to be more in the Middle East. So it's really precise. These meteor storms are not only is it like on one day, but it's even one area of the Earth that's going to see it. So we're very lucky to see that. But there will be a Perseid meteor storm coming up, and the U.S. is expected to see it, and that's going to be 3 years from now. So in 2028. So keep an eye out for that. Did you know about that? No? Okay. Get ready. Start planning. Okay. So here's some pictures from Comet Hale-Bopp that we took, and it looks like some other comets too. But it was wild. That was an incredible comet. We got a lot of people up here to see it. We even had the Sci-Fi Channel come up here and do a show. It was pretty neat. And he's not here tonight, but Dr. Gaidash took this comet in 1976, Comet West from Appalachian. So old school with film and camera and tripod. Okay, not that Google Pixel stuff. Okay, this is where you really had to work for it. So, all right, and so yeah, I kind of went over what the dust tail and the ion tail is called. So there's the word. So we talked about that. So speaking about that picture though, we had 500 people up here to observe the comet, and I told Lee, one of our astronomers, I said, look, you got 30 minutes. We're going to shut the door. No one's allowed in the 20-inch. And he took about 5 pictures in 30 minutes. And so this is actually in 2 different science textbooks. So we're real proud of that. It's really one of the best Hale-Bopp pictures taken anywhere. And then Halley's Comet from, I'll talk about that in a second. Let me see. So let's make a comet. I know we got the AC on, but is anybody still kind of sweaty and hot for how hot it's been? Because because comets are really cold. Oh, hey Drew, I don't think I have the bowl to mix it in. Anything, I guess. Yeah, thanks. So what we have is most of it is made of dry ice, which is carbon dioxide, is what we breathe. So CO2, you got carbon dioxide, okay, you got water, you got ammonia, okay, and because it's so cold, you have to wear these gloves. So it's 110 degrees below zero, so it's really cold. So, okay, okay. I got that. I think this one, the shape is good. Classic. Okay, we got to find our brown one. We've had that for 40 years. So, yeah, the plastic. It's okay. We'll do it with this, but it's kind of weird. Okay, so anyway, you'll see this carbon dioxide. So this is pure carbon dioxide, and it's called dry ice. So when I was a kid, my grandparents down in Tennessee had a farm, and we'd go down there and visit them, and we'd take back a whole steer, and I'd be the kid in the back of the station wagon with the steer, with all the packaged up with dry ice all over the place, barely being able to breathe because this stuff is like, because it's displacing oxygen. It's not poisonous, but it's displacing your oxygen. Not only was I freezing, I was also deprived of oxygen. but nothing's wrong with me. So anyway, so you have carbon dioxide, and then you got water ice. Okay, and then we got some ammonia here. All right, and then you got some rocky material. Which is, I think we just got some dirt or something. So rocky material. And, all right, we used to use kitty litter. And then you just kind of mix it up. We need a little more dry ice. A little more water. There we go. Oh, that's me. Okay. All right, hold on. We're just gonna go for it here. Yeah. And so so you got this dirty snowball, right? And typically when it's really far away from the sun, when it's out there past Jupiter, nothing's happening, right? There's not much sunlight, not much solar wind. But as it gets closer, it starts heating up and forming a tail. And you can see that there's darker areas around it, and then there's whiter areas where the tail is coming from. Jets of material can be coming off. So this is real different than the iron meteorite I passed around, right? So this is really cold, and it's made of ice, all the different types of ice we talked about, and some rocky material there. All right, and so anyway, that's. I think I got a picture of Halley's Comet. So we did get the Europeans were able to fly a spacecraft to Halley's Comet and got a picture of it. You can kind of see it has the darker area where the rocky material is, and the whiter area. Okay, and looks just like our little model. It looks just like our little. You can actually pick it up, believe it or not. So if you touch it on the water ice, it's not as bad. Okay, or it's just like walking on the fire coals, right? You just got mind over matter. Okay, all right. Yeah, workman's comp. So basically, let's talk about the numbers. Here's some big meteorites, right? You can car, and there's actually some videos of it coming down because it was Friday night, and this is '93, so there weren't cell phones, but it was Friday night. And what do people do Friday night in the fall? High school wise, what? Football. So they're filming a football game, and they see this thing coming down. So anyway, it hit her car, and actually the funny story is her parents were out of town, and so she called up. You're not going to believe what happened to the car, But they did okay. They sold everything, and they did pretty well. I forgot the exact value of it, but it was definitely more than the car. But anyway, let's see. So in terms of what's going to go on, basically, this meteor shower can be anywhere from 60, at the peak, 60 to 100 meteors per hour. Okay. Now I haven't observed it in the last couple years, but I've noticed it's it's getting lower. It seems that way. During the fact that we're going to have the moon will be interfering a little bit. So yeah, the moon will be out. So the moon is really the key factor. It's not going to occur during new moon. We're at full moon right now, right? Yeah, tomorrow's the full moon. So you really want, if it's a totally dark night, let's pretend it's totally dark, no moon out. You can see maybe one per minute, and I've seen that happen. Most of the time, it's even with no moon, you get, maybe one every 5 minutes or so, something like that. You'll maybe see, 10 in an hour or something along those lines. With seeing maybe 2 or 3 really bright ones. So don't think it's going to be like that meteor storm I talked about. What I've read online, most people are saying, that you'll notice 10 to 10 meteors per hour. Okay, and so what they're saying to do is to put the moon behind you if possible, so you're looking more in the darker parts of the sky. That kind of makes sense. The positive spin is that it dims the glare from the moon is that's what's going on here. Maybe I didn't explain it very well, but the glare from the moon is what's interfering with the fainter meteorites. Will see the real bright ones. Okay, so it's still possible. So, and what's really good about the Perseid meteor shower is that it's in the summertime. Okay, it's you're not freezing like for the Leonids in November or the Geminids in December. But the Geminids are pretty nice, but it's in December and it's usually really cold. So this is kind of nice. Get a blanket, find a dark place, okay, and observe and just have a good time. Let me see. I think that's pretty much it. So, yeah. So we're kind of repeating. So any questions on comets and meteors and things like that? Anything? Okay. All right. Well, are we ready to go with we got the moon coming up, right? So, hey, Art, what do we got? Oh, okay.
Hold on. Let me just
the mic.
take this here so that
it's so complicated now. We're live.
Yeah. Who's the question?
We got to have the mic in the audience.
Oh, I'm sorry.
He's like Phil Donahue.
Is there any particular area of the sky that we should be looking?
Yeah, I'm glad you mentioned that. No, there isn't. Just
Besides
wherever it's clear. However, what you do is if you were to take a map and you were to trace what you saw during the night, all the meteors. So here's our sky. All the meteors are going to come back to one point, and that point is what do you think? What constellation do you think that point is in? The Perseus. So that's why they call it the Perseid Meteor shower. So the Earth. Good slide for this too. Perfect timing. So the Earth is spinning into this debris field, and we are heading in the background is Perseus. So that's why it's called the Perseid meteor shower. But they're streaking everywhere in the sky, but they're coming from that one point. So if you draw the lines backwards, you have the Perseid. Yep.
One would also, just to add to that point, one would also argue that the meteors will enter our atmosphere at any number of places. So in some cases it might be behind me, other times it may be just finally coming in, in front of me. So quite frankly, literally anywhere that you see the darkest area is really the place you wanna look. Now you've got a question.
How long does it take for your eyes to get used to the dark so that you get the maximum ability to see it?
Yeah, typically 10 minutes to a half an hour. Okay. Now with the moon out, I don't know how important that is, but on a really dark night, it takes about a half an hour. Like when we're watching galaxies through the telescope, and if we're out here on a moonless night and we're looking at faint galaxies, I always tell people, go watch the planets first, come back here in about a half an hour, you're not going to see anything. And then when your eyes are totally dark adapted, it really helps. Now, one thing I didn't mention is what's going on when these things are going through the atmosphere. And, most of the meteors you see, the shooting stars, they are just tiny. They're like size of pebbles, let's say. They're very small. It wouldn't be something like this. This would be a bolide. If this was coming down, this would be really bright. And they're just heating up the atmosphere, okay? And something else comes in from outer space, and the space shuttle, and we used to come back in from outer space, and our other spacecraft, they have to have a heat shield. And we have a real space shuttle tile right here, all right? And I'll demonstrate how this works here. And then we have some more. Which ones do you want me to do? You want me to do this one?
Yeah.
Okay. Yeah, that's fine. And then this guy right here. You can see it's very fragile. Okay, in the shuttle program they had problems with tiles, and you can see why. Very fragile. So, yeah, I'm good. I already tested this too. I'm terrible at these things. There we go. So, and by the way, we're getting. Oh, that's what I was going to talk about. 40 years.
Yeah.
We've had this for almost. It's pretty low now. So I can feel it's very low. Oops. There you go. All right. So yes, that's pretty hot. 1,000 degrees or something like that. And when the shuttle or the meteor comes in, so here, this will give you the idea. The friction from the atmosphere heats it up. But this is just simulating how much the space shuttle tile can take. You know, it's glowing. So when the shuttle would come back down, it would look like a meteor, you know, in a way.
In Pennsylvania, they are militant about not having any kind of white light around, because what that's doing is, again, in order for us to see really dim objects, we want our pupils to be as wide open as possible, and so people, you know, are looking for their keys with their phone and with their light is really really sets you off. So that's why we'll typically, we often will actually just put red lights on in our lobby, and then but in the domes themselves we only have red lights, and we even keep those on a dim setting just so that you don't walk into things, but yet it keeps your pupils as wide open as possible.
Okay. Any other questions? Okay.
All right. Well, we will. The moon will be coming up fairly soon if it's not already up. Mars is probably set, but there's always something to see. We'll be doing some sky tours in a little bit. Typically, we'll see some satellites come flying by.
Any ISS passes?
No, ISS right now is passing by during the daytime.
Okay.
Normally, has everybody seen the ISS fly by at night? Okay, a bunch of you have. Basically, it looks like a star that's just slowly moving across the sky. It's not blinking. If it's blinking, that's a plane. And it actually passes by us about 7 or 8 times a day. Right now, it just happens to be doing that during the day, so that we don't see it. Okay. But the other thing also that's sort of interesting, especially for sort of if you're just starting to watch it, like you'll see this really bright light sort of moving across the sky, then all of a sudden it just turns off. Right. What's happening there is it's finally going into Earth eclipse. For what you do, because what you're seeing is really the sunlight reflecting off of the solar panels. It's not like the ISS has these big lights, shining down on the Earth. It's just the sunlight reflecting off the solar panels. And when it finally goes into Earth eclipse, there's no light to shine off of it, and that's where it turns off.
So if you're an astronaut at that point, you're going into the Earth's shadow, and you're going into nighttime. So you're seeing a sunset. And
the astronaut, it takes about 90 minutes per orbit. So the astronauts spend about 45 minutes in sunlight, and then 45 minutes in darkness. So the other thing we're going to try and do, are we going to be able to do the C8 with a?
I have it set up. I had it wasn't dark enough to get it.
Okay. We're now starting a new feature here. Is that we have one of our scopes that we're going to actually have a cell phone adapter right on it, so that you can actually just clamp your cell phone right on there and take a picture home, hopefully of the moon tonight. So anyway, we really very much appreciate you coming up this evening. And again, we have a rule here that you can't leave Kopernik until you look through a telescope. So we'll be checking on the way out.
By the way, I was streaming the stream, just so you know.
Oh, okay.
So I have my own channel here. All right.
And all right, well, thanks again. And we are still working on looking at who would be the programs that we'll be doing this coming fall. One of the programs actually will be a Binghamton University professor, Carl Lippo, who has done a lot of research on Easter Island and the moas that are there. Those moas that they weren't, it wasn't like they carved them from the stone that was sitting there. They carved them elsewhere and moved these multi-ton rocks. So he'll talk about Easter Island and thoughts about how to do that. So we'll look for our website, and we'll keep you updated. If you're not already on our email list, you can sign up from our website, and you keep up to date with what's going on. So thanks again, and we'll see you outside.